Behind the majesty of the giant Airbus aircraft that crisscross the world's skies lies a highly complex manufacturing process rarely seen by the public. Every modern Airbus aircraft is not the product of a single factory, but rather a combination of high technology, thousands of experts, and an interconnected global production network. The journey of a turbofan engine begins with the manufacture of its key components. The front fan blade is one of the most iconic components. In the latest generation of engines, this blade is made of a very light yet strong carbon and titanium composite material. Its aerodynamic shape is designed using high-level computer simulations. After production, each fan blade undergoes detailed inspection using lasers and digital sensors. Even microscopic imperfections can affect the engine's performance at high speeds. Components that pass the test are then sent to the main assembly line. The heart of the engine is a high-pressure compressor system, a combustion chamber, and a turbine. The compressor compresses air before mixing it with fuel in the combustion chamber. The hot gases from combustion then spin the turbine, which is connected to the engine's main shaft. This entire process takes place at extreme temperatures that they can exceed 1,500 degrees Celsius. Industrial robots also play a crucial role. Several processes requiring high levels of consistency are performed by automated robotic arms. For example, precision drilling of engine casings, or the application of thermal protective coatings. Robots are capable of working with accuracy that would be difficult for humans to achieve. Due to the highly demanding operating conditions, turbine materials are made of special nickel-based superalloys that are resistant to high heat. Some parts even have a thermally protective ceramic coating. This technology allows the engine to operate stably for thousands of flight hours. During the assembly phase, technicians install core components step by step using high-precision tools. Each bolt has a specific torque standard controlled by a computer. Digital sensors ensure that the tightening pressure meets specifications. If there is even the slightest deviation, the system automatically issues a warning. One of the biggest challenges in turbofan engine assembly is maintaining rotational balance. During engine operation, the rotors can rotate tens of thousands of revolutions per minute. Even the slightest imbalance can cause dangerous vibrations. Therefore, each rotor undergoes a balancing process using specialized machines capable of detecting minute mass differences. In addition to mechanical assembly, electronic systems are also crucial. Modern turbofan engines use full authority digital engine control, FADIC technology. This computer system automatically regulates engine performance, from fuel flow to combustion efficiency. Digital technology enables engines to operate more economically, safely, and responsively to varying flight conditions. On the production line, digital technology is integrated into almost the entire process. Each engine has a digital identity that stores component history, inspection results, and test parameters. This approach allows complete tracking from the start of production until the engine is delivered to the airline. Nevertheless, human skills remain a key factor. Many critical stages still require the experience of senior technicians, particularly visual inspections and final adjustments. In aviation, human intuition and precision are still highly valued. Once the assembly process is complete, the engine is not immediately shipped to the customer. The next stage is extreme testing in a testbed facility. The engine is mounted on a special structure and run under various flight simulation conditions. During testing, thrust, temperature, vibration, fuel consumption, and emissions are monitored in real time. The noise produced by the giant turbofan engine during testing is incredibly loud. Therefore, the testbed facility is designed with a special dampening system to reduce environmental noise. Testing can last for hours to ensure the engine fully meets international safety standards. The engine also implements the power-by-the-hour concept, a service model where airlines pay based on the hours the engine is used. This concept encourages companies to continuously monitor the engine's performance digitally after it is deployed in the field. Sensors on the engine transmit operational data for analysis using artificial intelligence and predictive systems. Through this data analysis, potential damage can be detected before it becomes a serious problem. A predictive maintenance approach helps reduce the risk of flight disruptions while lowering airline operating costs. This technology is a key advantage in the modern aviation industry. Amid growing environmental concerns, key focuses include reducing fuel consumption, lowering carbon emissions, and compatibility with sustainable aviation fuel (SAF). Some research is even leading to the development of hybrid and hydrogen propulsion systems for the future of aviation. Digital transformation and automation are also changing the way assembly lines operate. Augmented reality technology is being used to help technicians view work instructions directly through smart devices. Meanwhile, Digital simulations allow engineers to test new designs. Before they are physically manufactured, safety is a top priority throughout the entire production process. Every stage must meet stringent international certification standards. Even the smallest error can have a significant impact on flight safety. Therefore, a culture of discipline and quality control is a fundamental part of the work environment. The giant turbofan engine assembly line is more than just a place to assemble metal and mechanical components. It is a place where materials, science, aerodynamics, precision manufacturing, artificial intelligence, and human capabilities combine to create one of the most complex machines in the world. Every engine that leaves the production facility bears the fruit of the work of thousands of engineers, technicians, and cutting-edge technological systems. When an airplane takes off smoothly, carrying hundreds of passengers across continents, few people realize the complex processes that occur behind the engine suspended beneath the wings. Inside the engine assembly line, every bolt, turbine, blade, and sensor is assembled to exceptional precision standards for one primary goal: ensuring safe, efficient, and reliable flight. The aircraft engine industry will continue to evolve to meet the needs of global aviation. However, one thing that remains constant is the importance of innovation and quality at every stage of production. Is an example of how high technology and human expertise can combine to produce the giant turbofan engines that are the backbone of modern air transportation.